This question, this one question we are going to do. See, here we are saying the function is continuous at x0. I have to find a, b, c. That means limit x tending to 0 fx is already equal to f of 0. They are saying I have to find a, b, c. Now you see limit x tending to 0 means limit exists 0 plus fx is equal to limit x tending to 0 minus fx is equal to f of 0. Sorry, this is f of 0. Now I'll take these two equations first. So limit x tending to 0 plus fx greater than 0 is this equation. Under root of x plus bx square minus under root of x upon bx to the power of 3 by 2. The f of 0 c. Here it is f of 0. At 0 f of x is c. F of 0 is c. Put c. Now limit x tending to 0 plus, take x out. So under root of x, put a bracket, put under root 1 plus bx square by x, this whole under root, minus under root of x, and here it is b x to the power of 3 by 2. It can be written as half dot x multiplied xg. X to the power of half into x, bases are same, power are to be added, so you get x to the power of 3 by 2. That's the reason. Now do one thing, rub this. Sorry, I was supposed to rub it. Rub it now. Rub all this. Now this is equal to C. Now you do one thing. Take this bracket here. Now take a wait a minute. A bracket needs to be removed here. This is the bracket. Now the thing is this. Take this under root x. Take this under root x and this under root x common. And cancel with this under root the x under root x. देखो ये अंडर रूट एक्स है, ये अंडर रूट एक्स है, ये अंडर रूट एक्स है. इनको ऊपर से अंडर रूट एक्स निकाल लो और ये अंडर रूट एक्स कैंसिल कर दो. टेक आउट अंडर रूट एक्स common from the numerator. See what I'm saying is this. See what I'm saying is this. Look, take limit x tending to 0 plus under root x is taken out. Put a bracket 1 plus this x will cancel with this x, so this will become under root 1 plus bx minus 1 because and this is bx under root actually x, this and this cancels out and you get this. Now expand this using binomial theorem. Using binomial theorem you expand it. Using binomial theorem you expand it. So what you are left with, limit x tending to 0 plus, now you have your binomial theorem 1 plus half bx plus half minus 1 upon 2 factorial b square x square and higher order terms up to then this minus 1 will come. This minus 1 and this 1 will cancel out. This is bx. Cancel this x with all this higher order terms of x will remain. Put the limit. This all will become 0. ये पीछे वाले सारे 0 हो जाएंगे. This is equal to c. And so you will get half b plus your half b by whole b is equal to c. Cancel these b's, you get c equal to, you will get c equal to half. So c value you have got as half. Now let us rub all this. Let us now rub all this. Let us now start from here. Wait a minute. Let's start from here. Yes. Let me delete all this portion because again I have done the right side. Now I'll do the left side. Yes, here till here we will come here. Yes. Now we will take this into account. Now we will take, see earlier I took, पहले मैंने ये लिया था और ये लिया था. अब now wait. Now I will take this much part. Wait, let me go little up. Yes. Now I will take the first I took, पहले मैंने ये और ये लिया था. The first I took this and this. Now I will take the second part. That is this one and this one. And C I have already got half. C I have got half. C I have already got half. That was equation from the previous part. Now limit x tending to 0 minus sine a plus 1x plus sine x upon x is equal to f of 0, and f of 0 is what? Again c. F of 0 is again this c. This is equal to c. Now let's rub all this. Let's rub all this. Now the thing is, now you write this way. Limit x tending to 0 plus sine a plus 1 x upon x plus limit x tending to 0 sine uh, sine x upon x is equal to c. Right? C is already half. We have found C is half. So I didn't write any more C. I can write half now. I can write half now because C has been found to be half. So I can write half, no problem. I already found C half. Now you know what to do. Very simple. This limit will become 1, and this here you will do is you will multiply a plus 1 here and multiply a plus 1 here. Therefore, this now will become 1. This one will now become 1. So it will be a plus 1 into 1 from here plus 1 will be half. So a plus 1 plus 1 will be half. So a would be now, you can calculate a. A is half minus 2, that is a is minus 3 by 2. Minus, wait a minute, minus 3 by 2. A is minus 3 by 2. A is minus 3 by 2. So what all you have found? Let us find it out. So B we couldn't found. B हम नहीं निकाल पाए, C निकाल पाए और A निकाल पाए. A निकाल पाए, C नहीं निकाल पाए. We could not find B. We found C and A. We found C and A. So let's finish this problem here. Just a minute. Just a minute. Just a minute. Wait. Let me delete this portion and then explain you the whole actual thing from here. Okay. Let's delete this. Okay. All thing gone. Okay. Now you see what all you got for this question. This question. For this question, what all you got? You got C half. You got A as minus 3 by 2. B is arbitrary. B can be have any value. Arbitrary. So this is the solution. I hope you have understood now. देखो C की वैल्यू मिली थी, C की वैल्यू मिली थी, A की वैल्यू मिली है, परंतु B की कोई वैल्यू नहीं मिली है मुझे. B का मैं कोई इक्वेशन ही नहीं बना पाया हूँ. Therefore B is arbitrary. I got the value of C, I got the value of A, but I could not make any equation for B and solve it. So B is arbitrary. B can take any value, plus, minus, 0, half, whatever. That is free for B. B is free basically in some sense. Okay, we did this question now. Now I will not do this question. See, now the next question is, let us see the next question. The next question is, of course, this one. This one is the next question. What you do is that I think now you can do, take limit 1 minus, then you take this point. Then take limit 1 plus, you take this much. Then you see whether those two limits are same, and then you see whether it is equal to f at 1. F at 1 is 3. So this is the way you have to do. Now we are left with the last, this question number 17 and question number 18. See, they are saying show that fx is discontinuous at all integral points. So let us see. Take any a. Take any a belonging to z, integer. Any a belonging to z. So limit, I have to show that, it's very simple it is. Limit limit x tending to a plus fx is not equal to limit x tending to a minus fx. Very simple is the thing. This all I need to show. The shortest way is that instead of solving this equation, instead of solving this whole equation, can you see this greatest integer float function here? And you know the theorem. If f and g are continuous, we can say fg is continuous. But here, if this is not continuous, I have to check for only this for sure. देखो ये कंटिन्यूअस नहीं है, ये वाला, एक मिनट, ये वाला कंटिन्यूअस नहीं है, एक मिनट, ये इंटीग्रल फंक्शन कंटिन्यूअस नहीं है, फ्लोर फंक्शन, दिस फ्लोर फंक्शन इज नॉट कंटिन्यूअस. I need to check only this function at all in the integral points. I just need to check this function. This is not continuous, undoubtedly. So let's do it. If you want to do it, you can do it that way also. You can take the whole thing as one and do it. Look, now how will I do this? Wait, how will I do it? Let's see, how will I do it? This line which I wrote has to be written. Let me rewrite this line again. That is limit for, okay, write the solution like this. For a belonging to z integers, I have to show, so let's find RHL. limit, I can write direct h tending to 0, a plus h, then I have your whatever value is here, sine pi upon greatest integer function a plus h plus 1. Let us put the bracket here like this. Oh, sorry, this is the common bracket, plus sine greatest integer function a plus h minus plus 1 upon, this is the greatest integer function bracket, then we have divided by, this whole is divided by 1 plus a plus h, undoubtedly. Now you know, for the right hand side, the right side of a, let's, this is my a, this is my a plus 1, and this is my a minus 1. Between a and a plus 1 it will come to a because of floor function. देखो मेरे पास एक पॉइंट a है, a plus 1 है और a minus 1 है. ए और ए प्लस वन के बीच में वो ए पे आ जाएगा. मानो ए 2 है तो ये, अगर ये 2 है तो ये 3 है तो ये 1 है. 3 और 2 में ये 2 में आता है, 2 और 1 में ये 1 में आता है. Between 3 2 it comes to 2, between 2 1 it comes to 1, because this is the floor function, that is greatest integer function. So between a plus 1 and a it will come to a, इसलिए a plus 1 और a के बीच में a में आएगा. a and a minus 1 it will come to a minus 1. So this is the idea. Now we are between a plus 1 and a. We are between a plus 1 and a. Let me rub all these numbers. Wait. Let me rub all these numbers. This one, and this one. So let's take a plus h. A plus h, it will give me a. This will give me a, because a plus h is in between a plus 1 and 1. So limit h tending to 0. This will give me a. Now sine pi. This will give me how much? A plus h plus 1. So it will come to, that means you have a plus 2 here. So a plus 1 plus h. So it will come to a plus 1. A plus 1. This is the thing. Plus sine. Again, this will come to a plus 1 because of the same answer, a plus 1. Upon, you have a plus h. A plus h is how much? A plus h is again a. This will give me a. Wait a minute. Let me write it properly. Let me see. 1. It is coming to 1. And plus a. This whole bracket here. Now you can do one thing. See, limit. Let me take more space. Let me rub this. First, let me rub this one. This portion, let me rub all this portion now. Let me rub all this portion. And now, let me do this. See, let me now do this. Wait a minute. Yes. Let me take more space. Yes. Wait a minute. Let me take a little bit of more space. Yeah, this much is sufficient. Now see some stray marks here. Let's move it. Limit h tending to 0, right? H tending to 0. This is a sine pi a plus 1 whole by 1 plus a. This is the thing, right? Okay. Plus a times sine a plus 1, limit h tending to 0, a plus 1 upon a plus 1. So the answer is nothing but, just do one thing, remove the limits. Remove the limit and this is your right hand side. Just remove this. This is your right hand side. Let me write it. See, what I said is that this limit h tending to 0 was there. Now you just, I wrote it separately. मैंने इसको अलग अलग ऐसे लिखा था. ऐसे लिखा था अलग से. Wait a minute. Let me shift it little bit this side. Little bit this side. Okay. Now let's write limit h tending to 0. So this is same as a. Do not put this by this is 1 or this by this is 1. No, there is no sin h by h. देखो ये गलती मत कर देना यहाँ पे. इस टोटल को 1 मत बना देना. Don't make this 1. This is not equal to 1. Because limit h tending to 0, sin h upon h is 1. Wait a minute. Let me write it here. Is equal to 1. Limit sin h upon h is 1, but it is limit, here it is h and this is a. There is no h here. यहाँ पे कोई h है ही नहीं. these are just, तो इसको इसीलिए इस टोटल इसको वन नहीं बनाना है, दिस इसको वन नहीं कर देना है, डोंट मेक इट वन, दिस इज नॉट इक्वल टू वन, अंडरस्टूड. नाउ लेट्स रिमूव दिस लाइन, this remove all this, the confusion. So what you are left with, what is the now the answer? Just remove this and you will get your answer. This is your answer, this is your answer. Remove this also. Wait a minute, this is your right hand side. Now let us see the left hand side. Let us see left hand side. This is your RHL, this is your limit x tending to x tending to 0 plus fx is actually this. The right hand side is the whole of this, the whole of this. Now let's see limit h tending to 0 minus limit x tending to 0 minus, let's write directly straight away. The left hand limit, I'm writing the left hand limit, left hand limit, limit h, I'm doing it now directly, h tending to 0. Now you will have here is a minus h bracket. Now you will have this sine pi, then I think you have, wait a minute, let me see, yes, then this is sine a minus h minus plus 1 upon, I think 1 plus a minus h, and I think here it is a minus h plus 1. Let me just check once. Let me just check once. Let me check the question once. Yes, this is, yes, exactly right. Exactly right. Let us now bring it back down. This one, this one. I need to keep this one here. Now again, देखो, ladder network selling. This is A. This is A minus 1 and this is A plus 1. A minus H is somewhere here. A minus H is here and A plus H was here. A plus H यहाँ पे था, A minus H यहाँ पे. A plus H is here and A minus H is here. So for A plus H, the floor function was this. For A minus H, the floor function is this. So this will give me limit H tending to 0, A minus 1. Done. Now take the bracket, sine pi. Now this is a plus 1 minus h. This is actually a minus h plus 1 is same as a plus 1 minus h. So a plus 1 minus h will give me what? Somewhere here it will be. This will be a plus h minus 1 also would be somewhere here. Sorry, let me write it here like this. This one like this. Wait. This one like this. This is a plus 1, this is a plus 1 less than this, so a plus 1 minus h, this is minus, let me, this is minus h is here somewhere, so the floor will be a, so this will be a. Now see plus sine, this again will be a as with the same concept upon 1 plus a, 1 plus a minus h, sorry, a minus h. A minus h is this portion. So I'll get a minus 1, sorry. This will be a minus 1. This will be a minus 1. This minus and here it is all like this. Now see one thing. Check here. Check here. This one. Limit h tending to 0, a minus 1, a minus 1 sine pi by a upon, you can write this plus sine a upon a, because this one and this one will cancel out. So what you are left with, straight away answer. Don't cancel the sin a by sin a is 1. ऐसे cancel मत कर देना कि ये पूरा 1 हो जाएगा, ऐसा मत कर देना इसको. Let me write what I'm trying to say. Let me write it again. Limit, just a minute. Limit h tending to 0, a minus 1 sine pi by a upon a plus a minus 1 limit h tending to 0 sine a upon a. Don't make this 1. This is not a here, it is h. It is valid for this. Limit h tending to 0 sine h upon h is 1. Yeah, this is h and h and h here. H and h, so it is 1. It is a and h, so it's not valid. It is not 1. This is not equal to 1. देखो, ये है लिमिट h टेंडिंग टू 0 और ये क्या है, a है. ये वैलिड होता है h पे. h और h होना चाहिए, तब ये 1 देगा. ये 1 नहीं देगा, ये 1 नहीं देगा, नहीं देगा 1. कुछ भी कर दो. तो रिमूव दिस ऑल. नाउ यू अंडरस्टूड. रिमूव दिस ऑल. All, wait a minute. Yes. So your answer is now your this left hand is, see, your left hand is limit 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 x tending to 0 minus fx is nothing but a minus 1 sine pi by a upon a plus a minus 1 sine a upon a. See this one? See this equation? And see this equation. See this equation and see this equation. What is the right hand limit? This is 0 minus, no? And your 0 plus is here. Here. Can see this. So wait. This is wait a minute. This is your 0 plus. This is your whole of 0 plus. This whole is your 0 plus. Right hand limit. This is your right hand limit. Compare this. Compare this. Let's copy this from here. Wait. Let's copy this and let's bring it here. वेट अ मिनट लेट मी ब्रिंग इट हियर उसको कॉपी किया अब इसके नीचे लेके आता हूँ देखो क्या होता है कंपेयर करने में आसानी हो जाएगा इट विल बी इजियर फॉर अस टू कंपेयर वेट अ मिनट आई नीड टू डिलीट दिस पोर्शन wait I need to pick this portion again wait just a minute I need to pick this portion again and I need to bring it here I need to bring it there. Wait a minute, let me compare things so that my comparison becomes a little easy. Yes. Let me bring it little here, shift it little here like this. Can you see? Can you see the difference? देख सकते हो difference क्या है? देख रहे हो difference क्या है? ये और ये दोनों they are all different. This is different. This one is different. This one is different. So limit x tending to 0 plus fx is not equal to limit x tending to 0 minus fx. So limit does not exist. So limit does not exist. Does not exist. Does not exist.